pressure, pressure, pressure. Hi guys, welcome to my channel. I'm Kirandeep Kaur, and today's focus is gonna be pressure. So, before we go into more details, let's take a look at the question. John was on the 11th floor in an elevator when it broke and started dropping rapidly. Each floor has a height of 3 meters. When the elevator fell to the ground level and came to a halt, approximately what change in air pressure did John feel? A. 3.6 newtons per meter squared. B. 36 newtons per meter squared. C. 360 newtons per meter squared. Or D. 720 newtons per meter squared. So this is actually a very simple question if you know how to solve it. Now, when you're solving physics questions, you should be asking yourself a couple of questions. The first thing is it a conceptual question or is it an equation question? If it is an equation question, are you being given numbers to solve the equation or are you required to rearrange it to find the answer? If it is an equation question, that means you need to know the equation in order to be able to solve it. So with physics, the biggest battle is being able to not just memorize the equations, but actually understand them to be able to apply them. Another key thing is that you must know which units must be used for certain equations. So keeping all this in mind, let's relook at our question. I made this illustration from the question in order to get a better picture of what's happening. So we have John in an elevator on the 11th floor. When the elevator broke, it went all the way down to the ground floor. We're also told that each floor is 3 meters and the density of air is 1.2 kilograms per meters cubed. When answering a physics question that requires an equation, there are two things you can do. One, you can figure out what you know and what you need to know. So in this case, we can figure out the distance traveled, we know the air density, and we need to figure out pressure. The second thing that you can use in order to figure out which equation to use is look at the units. So for distance, our units is meters. For density, our units are kilograms per meters cubed. And if you look at the answer choices, the thing that you're solving for, pressure, the units are newtons per meter squared. Now, we should be familiar with the fact that newtons is the units for force, which equals mass times accelerations. Putting that in terms of units, that's kilograms times meters per second squared. If you have your equations memorized well, by looking at what you have and what you need to find, you will know that the equation is pressure equals to density times gravitational acceleration times the height. But let's say you don't remember the equation. There's no need to panic. You can simply just look at your units and figure out the equation on your own. So we know that we're given meters, we're given kilograms per meters cubed, but we need to figure out newtons per meter squared. So now we know that newtons is kilograms times meters per second squared. Now I'm just going to combine the two terms and see what we get. Like I said, we're solving for newtons per meter squared. We know newtons is kilograms times meters per second squared. So I'm going to just combine this. Let me just extend this. And since we're dividing by meters squared, I'm just going to put this under with the second squared. And now we can simplify this. And we get kilograms per meter times second squared. Now, from the previous information that we have meters and we have kilograms per meters cubed. Now, in order to get closest to the answer that we're looking for, we're going to have to multiply these two terms, and that gives us kilograms per meter squared. Now, I just want you to take a moment and think about what you have to do to this term in order to get this term. I'm just going to write them out side by side. So we have our kilograms, we have meters squared, but we need meters. So that tells us that we need to multiply by meters. Now, we do not have second squared in any of this situation, so we need to divide by second squared. Now, what is this the units for? This is why it's so important to know your units. This is for acceleration. Now, an acceleration is not given in our question. However, which is the acceleration that's most commonly used when it comes to such questions? Gravitational acceleration. And that is approximately 10 meters per second squared. Now, this obviously takes longer, so the best way is to have your equations memorized, know your units well in order to save time. But if you have time and you really want to be able to answer a question without remembering the equation, you can always use and manipulate the units like I just showed. Now that we've figured out the equation, it's just plug and chug. So the density is given, it's 1.2 kilograms per meters cubed times the gravitational acceleration, which is approximately 10 meters per second squared, times the height. Now, how do we figure out the height? Well, don't forget that the ground level is technically the first floor. From the first to the 11th is 10 floors, so 3 times 10, so 3 meters times 10, that gives us 30 meters as our height. Now, when you multiply all of this out, you should get 360 kilograms per meter times second squared, which in other words is newtons per meter squared. That means our answer is C, 360 newtons per meter squared. So that's it for this question, but I want you to be familiar with how to use this equation in any kind of question that's given. So whenever this equation is required to be used, there's certain things that you should look for. Keywords like pressure, air pressure, change in depth. And you should also not forget that fluids include not just gases. So it's not just air pressure that you're looking for. It could also be liquid. So another example that you could have possibly seen is a fish in like a water tank or a diver doing deep sea diving. So look out for these key words when you're looking at certain questions. When you see this question, it should be easy plug and chug answer. But it all boils down to, are you familiar with your equations? How good are you at using them? And how good are you at recognizing the question to know when to use them? So that's it for the pressure equation. If there's any topic that you'd like to see in the future, please let me know through the comments below. While you're at it, check out my other YouTube videos and don't forget to like and subscribe.